Welcome back to 3DPO. I appreciate you coming by to visit. Today we are going to be discussing the CN3D MMX. And I know that people have been waiting a long time for this video, and I apologize it's taken so long, but we've spent a long time making sure that everything is perfect. Everything is working, and we've made a lot of progress, including Blobifier. So we have a purge mechanism that's working pretty well right now. It should be released probably by the time that this video goes out. Documentation will be coming out of draft state and will be fully published, hopefully by the time that this video is released. A few things I wanted to talk about. So maybe some of you saw my video I put out last week, just a short 6-minute video just showing the MMX working. There was no audio or narration. It was just observing the behavior and operation of the MMX. We've made a lot of progress, so we're pretty happy with it. Managed to do a lot of 3D prints. The build video is going to be at the end of the video that you're watching right now, unless we split it in half. It's going to be a long video. It's probably going to be more than an hour and a half. So if you stick with me, I'll make sure that you get all the information that you need. Here in the intro part of the video, I'm going to explain a lot about MMX, a little bit about MMUs, some filament handling, why and how these things work, and why the MMX is a really good solution for any Klipper-enabled 3D printer. Well, this... first of all, I want to give a big thanks to Nadir at CN3D. I talk to him pretty much every day. And we've gotten to be really good friends, and this has been a really fun project to work on. I'm an old nerd, been working in technology for a very long time, so this is a lot of fun for me. I'm just happy to be part of the process. As of this release of MMX, the Hare companion, the Klipper software plugin for MMUs, is fully MMX capable now. It's even got its own logo for the MMU panel in mainsail or fluid. And I'll show you a screenshot or two of that, and we'll be discussing that further. We've been spending a lot of time on Blobifier to try and make this a whole solution, a full solution, right beginning to end. So that we have a good purge solution for multicolor printing that'll work well with the MMX. The one that we have for the Soval SV08 right now is really good. We've gone through a lot of iterations, a lot of filament. But Antonio at Layer Core 3D has been wonderful to work with. Again, I talk to him just about pretty much every day. This is a 4-lane. Soon to be expanded. Multi-material extruder. It works on a cam system. So there's one servo, one stepper. Okay. The servo selects the lane. The stepper drives the filament. And this is a Type A. A Type A MMU based on Hare. Okay. So a Type A MMU says that there's going to be lane selection by a servo or a stepper, and one stepper to drive the filament. Whereas a Type B would be something like the 3MS. Okay? And the 3MS has one servo per lane. One servo to drive the filament per lane. So it's independent servo control over each lane. Okay? So we're going to talk about a couple things, and I'm going to start on the list here. The Blobifier. So Blobifier will probably be released before this video is done. So we'll have a way to deal with and dispose of purge material during color changes. That brings me to another point. With the MMX and the way that I have my system configured, I have multiple sensors along the path. In our particular setup, I have 4 PTFEs, one each from each lane, that show up at a hub at my tool head. And what this means is that the filament is always in the PTFE parked slightly above the tool head rather than being fully retracted all the way to the spool like it would be on an AMS. So the bamboo AMS, every time that there's a color change, the filament is retracted all the way up into the AMS unit before another filament is rolled out of the AMS and then into the tool head before it's purged. My MMX is using the CAN interface. So I have 24 volts in high-low being supplied to my EBB42 right through that little port right there. Okay. There's also a little hole right there for USB. Now, if you're going to be using USB as a communication to the MCU, being the EBB42, you're going to need to provide 24 volts through the CAN interface to that board. Otherwise, you won't be able to drive the servo or the stepper. And so you can do something as simple as a 24 volt power supply, make sure it's at least 3 amps, and then just add a connector on the end, like that. Some users have reported that the servo, and we're using the 996 servo, which draws between 4.8 and 6 volts, it also draws a lot of current. So some are suggesting that we use an external power supply for the servo and just supply the data line to the servo. And that can be done very easily. Any 5 volt brick, pretty much, make it about 2.5 amps, all right, and provide that 5 volts to the servo and one data line. It'll behave just fine. That way you're leaving the draw off of the EBB42. And by the way, EBB36 work too. So if you don't have an EBB42 right now, but you have an EBB36, all the pins and everything all work. And I can prove it because I'm using it right now. For supplying 5 volts or 6 volts to the servo, one of the things that I'm actually using for our original Blobifier prototype used a servo to eject the blob, and I just put a 2596 buck converter, 24 volts to 6, and there'll be plenty of current available if you use this rather than a brick. Okay, just a FYI. Right. So in my configuration, I have 4 sensors. I have a pre-gate sensor, and that is the sensor that lives at the inbound side of the MMX. All right. There is no outbound or post-gate sensor. There is an option for that in Hare, and you could take care of that, and I'll talk about that in a second. And then there's a gate sensor, and what I'm using on my machine, and I'll be throwing some graphics up here as I talk, what I'm using on my machine is I have a hub, and on that hub I have, so on mine, okay, this is the blue version, but I have a yellow version, there is a micro switch with a 5mm ball bearing that sits inside of this slot, and this plugs into the top of my Xenomorph tool head. All right. And the reason that I use this one in particular, and I need to get it refined, maybe Nadir can help me out with that, is that it has an inspection cap. And this inspection cap allows me to have collets, okay, instead of the ECAS connectors. But it also lets me, right? So I have 4 pieces of filament that are loaded full time into 4 PTFEs if I'm using 4 colors. And if I have any issues, it's really nice to just be able to open up the inspection cap and see what the condition of my filament is. Maybe I have a jam, maybe it's curved, curled, who knows. Okay. The extruder sensor, so in my, let's talk about extruder sensors. In my toolhead, my xenomorph toolhead, CN3D xenomorph toolhead, I have 2 filament sensors. I have one that's just above the gears of the extruder, right? In my case, the orbiter. And then I have one just above the entry into the PTFE of my Rapido. Okay, so I have a Rapido UHF. All right, so let's talk about it. All right, so I have just above the entry point into the PTFE of my nozzle, of my hot end, I have a filament cutter, and just above that filament cutter is my tool head sensor. Okay, and I'm going to show you up here on these graphics or wherever they are. Okay, and they're going to show that. And so a couple things with the filament cutter. The cutter is just above the entry of the hot end. Okay, and so what I can do is during a color change is I can pull the filament. I can pull the filament back before I make the cut, right? So I'll pull it back, push it back in a little bit, get rid of the deformed end, pull it back again, and cut it. And once I cut it, there's very little, there's only a tiny bit of filament left in the, say right there, left in the hot end. And so when the next color comes inbound, I have less filament to extrude in order to clean out the nozzle. Okay, so works really well. I've been working with Antonio at LayerCore 3D, and Antonio is the one that's going to be releasing the Blobifier. He's done an amazing job. We worked on it every day together for a while. I used a couple rolls of filament, and I have boxes of parts that didn't work, but now we have a really good system. Can't wait to see that in release. We could go to one more sensor. We could get rid of that gate sensor, and we could put in Blinky. Blinky not only detects that there's something there, but it also detects movement. There's a little wheel inside, and it just and the wheel has little spokes on it, and as the spokes go round and they cut the light off from a sensor, we can see rotation, and we know that when filament's supposed to be moving, we can see it moving into our tool head. And by the way, Blinkies, I think like $4 on AliExpress. All right, so if we talk about hubs, there's all kinds of ways that we could deal with hubs, right? So the idea here being that the MMX will work on any Klipper printer, right? Any Klipper-based printer, because we have the ability to load Hare, and Hare has all of the intelligence required to drive the steppers, to drive the servos, to be able to determine condition of all the sensors. A really interesting idea, and these guys did a lot of work. It's really quite phenomenal. So let's talk about these gate sensors. So there's a couple ways we can do this, right? We could have, instead of having 4 filaments that go all the way to the tool head that are sitting in there full time, all the time, what we could do is we could have the gate sensor a little bit closer to the MMU, have all 4 lanes go into each one of these connectors like it would be in this armored turtle hub, and then we have our sensor, our gate sensor, but it comes out as one PTFE full of filament. But what that means is that every time we do a color change, that filament has to come back past this sensor before we can have an open lane to drive another filament through that PTFE. So that's why having all 4 PTFEs at the tool head at the same time is a very viable solution. And when you're working on, like my machine's a SV08, it's not like having 4 PTFEs sitting at that tool head all the time are going to cause any issues. We can drive the crap out of that tool head. Just make sure you do your input shaping, your resonance compensation after you add, all of your external filament connections, whatever they may be. There's a bunch of ways to do it. Nadir has one like this. I made this one. It comes in 4 and 5, so we can have a bypass, right? So we can have the 4 filaments coming in, but we can also have a bypass with a manually loaded filament side. This is the one that he has for the for V4 tool head and xenomorph. These screw down. It's a good one. There's a million of them. Okay, they're all over the place. So, okay, so I think that covers hubs. Filament buffer. We don't need a filament buffer with MMX. One of the setup procedures for MMX using Hare is to determine how much filament is being driven per step on the stepper motor. And it's very accurate, and we can, I have not had any issues where I've been deprived of filament when requested by my tool head. So I don't need to use a buffer. However, there's buffers, right? So we have the buffer for a box turtle being a type B. Each lane is individually driven, and again, there's only one PTFE coming out of box turtle. So what we can do is, in order to make sure that that we synchronize across those multiple steppers that are driving each individual lane, is we can have a compression and decompression side of a filament buffer. We have a decompression side where we have filament, and as the amount of filament is being reduced, we're actually pulling this end towards the filament. We get to this end, we trigger a micro switch, and then we feed more filament. We can do that in increments of whatever the length of this is. Okay, all this can be calculated. It's all math. So some of the benefits are, right. So let's take a look at what it was originally based on. Right, the Pico MMU LH Stinger. There are no sensors inbound or outbound. This one has a servo-driven cam. The original actually used a string, like a nylon type of string. This uses the EBB42, but as you can see, there's no sensor connections. All there is servo and stepper, and that's it, right? So we bring a CAN connection, and we have to look for external sensor stimulus elsewhere. All we can do is tell this guy to choose a lane and drive filament. The MMX has more intelligence because of the extra sensors that are there. Then we also have the task of filament management. As we're drawing filament or we're bringing filament back, now in my case, because I have four PTFEs that all arrive at my tool head at the same time, and they're supposed to all be full of filament at the same time, and they're at a parking distance from the tool head, maybe 20 millimeters, maybe 10 millimeters, whatever you choose, right? Because this doesn't just have to work on my SV08 with a CN3 tool head, right? It can work on any Klipper-based machine. So wherever I decide to park that filament, there's going to be some retraction at some point, whether it's 30 millimeters from the hot end back, or if I'm using this solution right here is my gate, I may be pulling more back. Now we have extra filament that is just being ejected from our MMU, and we need to buffer it somehow going in the backwards direction. I use the Filamentalist. So I really like the Filamentalist. I have like 6 different kinds. I've just been experimenting. Right now I'm actually working with the version 3. I love it. Here's the entire kit. I'm going to change cameras here real quick. So here's the entire kit for Filamentalist. Everything else is printed, right? It's just this very clever design, right? So here's a locking bearing. It only goes one way, okay? It only goes one way. These little O-rings, I bought a bag of like 100 for $5. You can use rubber bands. I decided to print mine in TPU. And a few bearings, 608s, okay? 608 bearings, very inexpensive. I'll show you how it works, okay? So the way that it works is, because it has that bearing that only runs one way. You know, I'm going to go to this camera here. Yeah, let's go to this camera. All right, so so say I have a piece of filament, okay? Piece of filament, and the roll is sitting here. Okay, I'm going to bring this camera up a little bit. There we go. The roll is sitting here. So I just load the filament from the back, and it goes up underneath the spring-loaded bearing and those rubber O-rings. And now what we have is a drive going this way. In other words, there's when the filament's being pushed backwards, that one-way bearing is engaging the rollers and rewinding the filament onto the roll. Going in the opposite direction, I can hold this roller in place and it will move freely out to the MMU. When the MMU sends filament backwards, the Filamentalist engages the one-way bearing and rolls it back onto the roll. I love it, okay? I'm looking at a lot of different possibilities for this. I redesigned a couple parts. One of them I want to show you is, and I'll show you also in the build. Let me go to this camera right here. Let's go to this camera right here. Get rid of my notes. All right. So on this end, I built this cover that has these openings so that I can get to the stepper motor and the servo. Okay, it just seems to make it easier for me. Also remember that the MMX has this frame in the front that will go sandwich right onto the CN3D top hat. Okay. I also made a little spacer that goes right there that allows me to begin the testing without any cover on this end. I'll be providing all of this. Gate 3 requires a little indentation in the end because it was running into this bearing that has about a 1 millimeter rise. I don't know if you can see that. Okay, so I have a new one of these. Remember that the cam and the idlers are printed in PETG, right? Shiny, slippery PETG. Shouldn't have any problems that way. And the last one is on the inbound side of the gates themselves, the gate assemblies. I put a little bit more of a recess for a 4 millimeter PTFE to go further in here so that there's absolutely no resistance inbound or outbound of the of filament on the gate, on the lane. Okay. Remember, it's 0, 1, 2, 3 going that way. And I think that about covers it. Oh, one more thing. The rods, the 5 millimeter rods, according to the bill of materials, are supposed to be 134 millimeters long. if you look at my build, if you look at my lanes and my gates, do you see how nicely printed those are and how tight those lanes sit against each other? Right? I mean, it's right. If you do a really nice print, okay, and use recommended settings of 4 or 5 walls, 20 to 40, 40% gyrite infill, you're going to have beautiful prints, okay? And here's some shameless promotion for CN3D. Put the logo on the side. All right. So I can't get this to move in all the way, which means I can't use this bracket on the side in order to sandwich this on the top hat, because my lanes are so perfectly perpendicular to each other. I could take 4 millimeters off of the length. So that means that my 134 millimeter, 5 millimeter rods could be 130 millimeters, and they would be perfect for this. Okay? Just letting you know. That also means that my rod for the threaded rods, as you can see, the threaded rods are also, they stick out pretty far. This works. There's not a problem. But I have all this extra threaded rod sticking out. I could take 3 or 4 millimeters off of that, no problem. Have a nice clean build and be able to put the covers on. Now this is the stock end cover right here. And I'm telling you, if you have this spacer in here, which I'll give you the file for, this spacer, you can put this cover on and it'll fit. But see, right now, it's just too far away. It's just too far away. I got 3 or 4 millimeters of gap there that I can't do anything with. So don't get mad at me, Nadir. I'm just reporting to you. It's being reported to me. Okay. Also, the documentation should be coming out of draft very soon. I'm hoping within the next 2 days. But of course, here is a 3D print. This is my first successful 3D print. And so I just wanted to show it off. So I had a bunch that didn't quite work, but when Antonio and I got down to it and configured everything, it worked out really well. I'm really happy with it. We even did purge to infill, which worked, and yeah, really happy with this. So, of course, the manual is available as in its current state on printables. I have a working version that I'm using, and I'm getting better with the Voron template. It's not perfect, but I'm getting better at it. I tried to make sure that when in the build video that I noted the screw size for every screw that I used. I'll try and add the screw sizes. There's only a handful of screws to the build video, and that'll be coming up here shortly. So yeah, let's go build an MMX.